The topic of today's lecture is Java lists. All right, so if you haven't programmed in a language like Python or Java before, so if you've only done C, then you've only seen arrays. A list is I guess the easiest way to describe a list is it's a more powerful version of an array. And it eliminates many of the disadvantages that you have when you work with arrays. So technically, it provides functionality of the list abstract data type. Did they tell you how to implement a list in your data structures course? Fascinating. All right, so what did they tell you how to implement then? Like stack, queue, but oh, linked list. So this, yeah, same thing. So well, similar idea. So if you implemented a linked list, then you have an idea of what a list is. Right? Now, Java lets you choose between many different kinds of lists. Right? So the one we're going to look at today is array list. If you've seen a linked list, that's good. Java also has a linked list class called big L linked list. It would behave probably similarly to the one that you were taught how to implement in your data structures course. If you want to read about the documentation, you can follow that link there or just Google array list. Now the slides are going to reference Python quite a bit. I should have changed these to C at some point, but these are stolen from CISC 124. So they're going to refer to Python. So anywhere it says Python, just ignore it. So when you work with a Java list, they're a bit different than, well, lists in a language like Python. But they're similar to a C-cell array in that you can only hold elements of one type. Right? So in Java, if you make a list and you want to hold a bunch of, say, strings, then you need to put that element type inside of this funny bracket notation. And I'll show you how to do that shortly. So this bracket notation is a feature of the Java language that's used when you are working with what are called generic classes. Right? So a generic class is a class where you are allowed to specify one or more types that are parameters for the class. Right? So for a list, one of the parameters is what is the element type of the list. Right? And so you specify that as a generic type argument. And I'll show you how to do that in just a second. Oh, there it is right there. Right? So when you make an array list, right, you need to say what is the element type that's in the list. Right? So that's where this funny bracket notation the angled bracket notation comes in. Right? You put the type inside the angled bracket, and now your entire type becomes array list of string. Right? So I got a variable t that can hold an array list reference. Right? So to create the array list, I use the new operator, right, that we learned in the last class. You call a constructor. So when you call the constructor, it's array list, and then again, angled bracket string, and then the round brackets. Right? So that makes a new empty list, right? So a list with nothing in it. You're working with a more modern version of the language, so you can drop the string on the right-hand side. So you can drop the generic type on the right-hand side, and instead you can just write new array list, angled bracket, nothing in between. Right? You'll also find that you can leave off the angled brackets. So you could just write new array list and then round bracket, round bracket. That does in fact work. The compiler will complain. You'll get like an orange thing in Eclipse and it'll say the generic type is missing. It will still compile and it will still work. If you're programming in a modern version of Java, you should put in the doubled angle brackets. All right, so one of the limitations of the Java's generic types is that you can't make a list. Sorry, that D is a mistake. You can't make a list that can hold elements of a primitive type. Right? So for example, you can't make an array list of int, which is unfortunate, but that's just the way it works in Java. Right? So if you can't make a list of int, what do you make instead? Right? So this is why this is one of the reasons why these wrapper classes exist. Right? So we saw the class integer, we saw the class double, we saw the class character, I think. Right? So those classes, I told you, they hold information about their corresponding primitive type. Right? So integer holds information about ints, right? Like the largest and smallest value and the other things. Right? But it turns out it's also what's called the wrapper class for int. Right? So every primitive type has a corresponding wrapper class type. And these wrapper classes are what are used when you want to work with a generic type and you want your list, for example, to hold a primitive type. Right? So instead of holding a primitive type, you hold one of the wrapper class types instead. Right? Okay, now similar to string, the wrapper classes get special treatment by the compiler. Right? So you can do things with the wrapper classes that you can't do with ordinary reference types. So here I've got an int I, right? So that's primitive. Its value is 1, so that's fine. That works, no problems. Right? Now on the next line, I've got a big I integer, j, right? And I set its value to I. Right? Now j, its type is big I integer. It's not int. Right? But because integer is the wrapper type for int, the compiler will silently convert between the two when it needs to. Right? So here, we've got an int on the right-hand side. We should put that into an int variable. Right? But instead, we're going to put it into an integer, and that's just fine. What Java does is it takes the the value 1. It converts that to an integer object that represents the value 1, and then it stores a reference to that object. Right? So that process of converting a primitive type to the wrapper type is called auto-boxing. Right? So we say that the primitive type is boxed to form the reference type. When the compiler does it, it's called auto-boxing. Right? And you can do the opposite. So if you have the wrapper type, so j, right, and I want to store its value in a primitive type, well, you can do that too. Right? So the compiler looks at the reference j, it asks for its int value, right, and then stores the int value in k. Right? So it unboxes, or auto-unboxes, the wrapper type to give you the corresponding int value. Right? So it looks like you can seamlessly use or seamlessly switch between the wrapper type and its a primitive type and its corresponding wrapper type, which is true. For the most part, you can. You shouldn't do that, though. If you need the primitive type, or if you want to use the primitive type, then you should use the primitive type. The primitive types are much faster than the wrapper types. Right? So the primitive types, the compiler, well, the virtual machine can compute stuff with the primitive types much faster than it can compute stuff with the wrapper types. Right? Yes?
Are I, J, and K all stored in different places?
I and K are, because they're two separate int variables, so those are definitely separate. J is also stored somewhere else in memory, yeah. There's actually 4 things in memory here. There's the int variable I, there's the int variable K, there's the integer variable J, and then there's the integer object that was auto-boxed here. So there's actually 4 things happening here. Okay, so if you want to make a list of int, for example, you don't. You make an array list of big I integer. Right? If you want a list of double, little d double, then you don't. You make a list of big D double. Right? And if you want a list of car, you instead make an array list of big C character. Right? So you just use the corresponding wrapper type, and everything happens. Seamlessly. Do I tell you why? Hang on, I just want to quickly check. Okay, I don't actually tell you why. So the reason why you can't make a primitive type, you can't make a list that holds a primitive type, is because this feature, this generic type feature that you see here, this was added in version 5 of the language. Right? So it was added quite late into the Java language. When you add a new feature to a language, you have to be careful about breaking all previous existing code. So the only way that they could do this without breaking everybody's existing code is to introduce these wrapper types. So instead of array list int, you now have to make array list integer. Right? It's possible, it would have been possible at the time to make an array list of int, but everybody who had written Java code before, who used array list, would have to rewrite all of their code in order to deal with the changes that they would have had to make. Right? And so in general, so people who design languages that are used by many, many other people don't like to make changes that break other people's code. So instead, we're stuck with this somewhat clunky wrapper class type. Okay, so even though we have to use a wrapper class, generally you don't really care, right? You just make the substitution of int and integer here, right? And you just let the compiler take care of everything. Right? So when you use a list where the elements are a wrapper type, you can just pretend that the list really contains primitive elements. Right? So the add method here for list, add appends an element to the end of the list. Right? So t add 100, so that's an int, right? It's not an integer. right? T add 100 adds the value 100 to the end of the list, right? So T here is empty, right? After adding one element, it now has one element in it, right? So unlike an array, right, which always holds a fixed number of elements, lists can grow and shrink as they need, right? So here it holds one, now here it holds 0 elements, now it holds 1. If you keep on adding, it'll hold 2, then 3, then 4, and so on, and so on, and so on. You can take things out, and the number of elements decreases, right? So the size of a list changes dynamically as you add and remove elements from the list. Right? So here, you really, because this is a list of big I integer, that really should be an integer reference here, right? Because you want to add another big I integer object to the end of the list. But the compiler just converts that 100 to a big I integer object and adds it to the list for you automatically. Right? Here we get element 0 out of the list. Right? So get is the method that you use to retrieve an element from the list, right? And you do it by index. So this would be like t square bracket 0 if you're using an array. Right? So t get 0 gives you back the first element in the list if it's there. Right? Now that's an integer reference, but you can store that in an int variable because the compiler just converts the reference to an integer to a int value, right, by auto unboxing the reference. Right? So you can just pretend that the list really holds a bunch of ints, except for one particular case. Right? There's only one that I know of. So there's a remove method in list. Right? So there's actually 2 remove methods in list, which is the problem. Right? So you can remove an element. You can either remove an element by its value. Right? So here, when you look at that line of code, you might say, oh yeah, I'm trying to remove the element 100 from the list. Right? Because back here, we added 100. And now here, we're going to try to remove 100. So it looks like, yeah, I want to remove by the value of that I'm passing in here. Right? And there is a method that removes by value. Right? So there is a method that will take an integer value whose value is 100 and remove that from the list. The problem is that's not an integer value. Right? That's actually an int. Right? So the problem is there's a remove method that takes in an int as its parameter. And that method removes by index. So that tries to remove the element at the 101st element from the list. And so this barfs if the list only has one element in it. Right? So this is the one case where you have to be careful about using the primitive type and the wrapper type. Right? It only happens when you have a list of integer. If you actually want to remove the value, the object whose value is 100, you need to pass in an integer whose value is 100. Right? And there's multiple ways to do this. You can use integer.valueOf, and that will make an integer object whose value is 100. You could write new integer 100. That would also work. What else could you write? On the previous line, you can make an integer variable j and set it equal to 100, and then remove j. That would work as well. Right? But as soon as you pass in an int, Java thinks that you're calling the remove method that removes by index. OK. What can you do with a list? So you can do a whole bunch of stuff with a list. And this is not complete. There's many other things that you can do with lists. So how do you make a new list? Well, you call the no argument constructor, like that. Right? Let me show you this in Eclipse instead. Where is it? Here it is. OK, so I've got this little class called listDemo. It's just got a main method in it. I'm just going to call a bunch of list methods. Right? So step 1, I'm going to make a list. Right? So we do it by calling the no argument constructor. Right? You can print a list, which is handy. Right? So there, I'm just going to print out the contents of the list. And then I'm going to print a blank line. Right? I've got a bunch of stuff commented out. So when I run this, we should just run those 3 lines of code there. Right? And so when you run that, you end up with this, square bracket, right? So that's telling you that the list is empty, right? You have a list of size 0. If you want to get the size of the list, I guess I didn't put that one in, right? If you want to get the size of the list, then the method is called size. So t.size, and then we can print out the size of the list. Like that. Right? So if you run that, you're going to get 0. So that list is empty. Okay, there's also a method called isEmpty. Right? So if you want to know is a list empty, and it turns out you actually want to know this quite a lot, right? Because the empty list or an empty array is often a special case, right? There's a method for it. So T is empty returns true if the list is empty, right? It returns false if the list is not empty. And size gives you the number of elements currently in the list, right? Add appends an element to the end of the list. So let's try that out. Okay, so I'm going to uncomment that, and now I'm going to comment that. Okay, so we're going to add the element first, the string first, to the end of the list, and then we're going to print the list. Right, so the list is empty, its size is 0. Now it has 1 element in it after adding. Right? If you printed out the size, it would all be 1 at this point. Right? And you can call add as many times as you like. Right? There's no built-in limit to the size of a list. Right? So I can add next, then I can add last. Right? And remember, add always adds to the end. So we start with first, then we're going to add next on the end, and then we're going to add last on the end. Right? So first, next, and last. Right? So now you've got a list of size 3. Okay, how do you get an element out of the list? Well, there's a method called get. Right? So get is like using the square brackets with an array. Right? So get 0 would be the same as getting t square bracket 0. Right? And that returns a reference to the element that's in the first location in the list. Right? So I have a list of string. Right? So get's going to return a string. If I had a list of doubles, then get would return a double. Right? If I had a list of dates, list would return get would return a date. Right? So it returns the type of the element that's in the list. Yeah? No, get just returns the item. Yeah. Okay, so let's run this. Right. So when you call get, then the element that you get is the string first. And notice that the list doesn't change. Right? So the list is still first, next, and last. So get does not change or modify the list. If you want to change the list, then that's set. Right? So if I want to replace an element, the designers of the class decided to call the method set. Why they didn't call it replace, I don't know. Set confuses people. I'll explain why in a second. So the way set works is you pass in the index of the element that you want to replace, and then you pass in the replacement value. Set returns the old value that was replaced. Right? So here, if I replace the element at index 0, that's going to replace the first. Right? I'm going to replace it with the string front. So set will return the string first when as old. Right? So when I run that, right? So it replaced the string first, right? And the string front is now the first element of the list. Okay, now why is set badly named? So set's badly named because people think you can set any element of the list. Right? So for example, t set. So this list has 3 elements in it, right? 0, 1, 2, right? So the highest index is 2. People think that you can just set the element at index 3, for example, to something. Oops. Right? So you have to remember that set is replace. It's not the thing that adds to the list if it needs to. Right? So set is replace. So it will only replace something that already exists. Right? So if you run this, you get an exception. Right? So exception, blah, 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 blah. You get the index out of bounds exception. Right? And it complains index 3 is out of bounds for a list of length 3. Right? So you can only set elements that actually exist in the list. Right? If you start with an empty list, don't say tset 0. It won't work. Right? So that doesn't work. Okay, can you insert into the middle of the list? And the answer is yes. Right? Why they didn't call it insert, I don't know. They called it add. Right? Which is confusing again. Right? Add adds to the end of the list, but now we're saying it inserts into the middle of the list. Right? So add, pass in an index, right? And it inserts an element at that index of the list. It pushes everything else down the list. Right? So tadd2 inserts an element at index 3. Anything at index 3, 4, 5, 6, or 7 that's in the list gets moved one to the right. Right? So it gets moved to index 3, 4, 5, 6, and 7, and so on. Right? So everything gets shoved over one to the right and to make room for the new element. So if we run this, oh, sorry, I need to do this. Okay, so our list here is front, next, last. Right? If I insert or add at index 2, so that's 0, that's 1, that's 2. Right? So the inserted element will go there. Everything that's currently in list from that point to the right will move one to the right. Right? So when I insert middle, I get front, next, and middle, and last moves over one position. Right? And if there's more elements after last, they all get moved over one position. You can remove by index. Right? So here, T remove 1 removes the element at index 1. Right? So that's 0, so it's going to remove next. Right? Now when it removes that element, everything after that element moves over one to the left. Right? Because it doesn't leave a hole in the list. Right? So when you run that, right? So there we start with front, next, middle, last. Remove the second element. Right? So that's going to remove the next. Right? The resulting list is front, middle, last, and it returns the removed element. So the caller still has the removed element if they need it for some reason. Right? Can you copy a list? The answer is yes, you can copy a list. And it's easy to do. There's no method called copy or clone though. Right? So to copy a list, you just make a new list. Right? So I'm going to make a new list U. Right? We're going to call the new operator. Right? We're going to use a constructor. And this time we're going to pass in the list that I want to copy. Right? So if you look in the array list or the array list class, you'll find that there's a constructor that doesn't take in a list somewhat unusually. It takes in what's called a collection. And it turns out that in Java, a list is a collection. So I'll explain that a little bit later on in the course. But for now, if you want to copy a list, that's one way to do it. Right? Just make a new list and pass in the list as pass in the list to copy to the constructor. Right? So I'm going to end up with a list U and a list T, and they should both be identical. Right? So in other words, they should be both equal. I guess I should do that next too. Okay, so there's my list that I want to copy. Right? U is the copy, so U is front, middle, last, and the list that was copied is also front, middle, last. Right? Are they equal? Right? So Boolean boo equals T dot equals U. Like that. Right, so if you want to test if two lists are equal, just call equals. Run that, and yeah, they're equal. Right, so equals, right, which we use with strings, right, it turns out every object has an equals method, right, lists included. So two lists are equal if they have the same length and if they have the same sequence of elements. Right, if you ask the question, are T and U the same object? Right? That's what T equals U means, right? Do they refer to the same object? The answer is going to be false. I guess I should change that to same object. Right? And so now it prints false. Right? So don't use equals if you want to test if two lists are equal. Right? Make sure you use the equals method. Okay, so when you make a copy, the question is what type of copy was made? Right? And so it turns out if you make a copy of a list by calling a constructor, then you really do get a second list. Right? The second list really does have references to the elements in the other list. Right? So in other words, oops, sorry. Oh, I can't, no. Oh, here, yes. Okay, so this is showing that they're independent. So I'm going to take U, and I'm going to add a new string to the end of U. right? So I'm going to add really last to the end of U, and then I'm going to print out U and T, right? So you can see that U changes, right? It's the list front, middle, last, really last. But the original list, T, does not change, right? Front, middle, last. Right. I guess I should show you something else, right? So that copies a list, that line there, right? So if you're going to copy a list, make sure you do that. Don't write the following. So U equals T does not copy the list. Right? So if I run that code now, right? So are they equal? Yeah, they're equal, right? Are they independent? No, they're not independent. When I add an element to U, it also adds it to T, right? And so that line right there, right? What that actually says is U and T, they both refer to the same list, right? So in other words, if you're thinking in C, right, and you're thinking of references as just pointers, right, then T is a pointer to a list, and U is a pointer to the same list that T points at, right? In other words, U and T are the same pointer. Someone has started their 124 office hour, right? So that does not copy a list, right? That makes another variable that points at the same list that T points at, right? To copy a list, right, make sure you call new, right? That's the easiest way to remember it, right? Whenever you need a new object, new has to be called somewhere. And so to actually make an independent copy of the list, you have to call new at some point. What else do we have here? Okay. Can you add, now that we have two lists, can you add the elements of one list to the other list? Right? So in other words, can I join two lists together? Right? And the answer is yes, you can. Right? So the method add all takes all the elements that are in U and adds them to T, but it doesn't change U. Right? So U stays unchanged, T changes. Right? So if that's what U and T look like, then after calling add all, T looks like front, middle, last. Right? So front, middle, last. Followed by everything that was in T. So front, middle, last, really last. And so there's your front, middle, last, really last. Right? Notice U doesn't change. Right? So add all does not modify U, it modifies the list T instead. Can you sort a list? And the answer is yes, you can sort a list. You don't have to write your own algorithm to do so. Right? So to sort a list, there's a method in a class called collections. Collections is a class that has a bunch of static methods that operate on lists. Right? There's a sort method in collections that will sort a list. So if I run that, now if it's strings, it's going to sort by dictionary order. Right? So we have front, front, then last, last, middle, middle, and then really last. Right? Everything's sorted in dictionary order. Yes?
Out of curiosity, what kind of algorithm do you use?
Java uses merge sort. There's another way to sort a list as well. So you can also ask the list to sort itself, but the syntax is a little bit odd. Right? So if you want the list to sort itself, instead of using collections, you can call the sort method. But the sort method actually has a parameter. So if you, without telling you what the type of that object that you have to pass in is, to sort a list using the default sorting order, you pass in null. Right? And this works as well. Can you sort a list of everything? The answer is no. You can't sort a list of any arbitrary type. Right? There's some restriction on the element type for you to sort a list. Right? But string satisfies that restriction. And we'll talk about that restriction a little bit later on. Right? And so there's a quick tour of how to use a list. There are a few other useful methods that we'll show you now. So that table there has everything, I think. Oh, I didn't show you contains. There's a method called contains that returns true if a list contains a specified element. Right? So if the list T contains the value equal to val, it'll return true. Sublist is handy too. So sublist lets you get part of a list. Right? So I can get a contiguous chunk of the list. Right? So I can get, say, everything after the first element. Right? And so you pass in a starting index. You pass in an index that's one past the ending index that you're interested in, and it gives you back that part of the list. Okay, there's some other methods as well that are handy. So in the collections class, there's lots and lots of methods. Two, or I guess three here, three of the handy ones. So frequency, that counts the number of times the string ABC appears in the list T. Right, reverse will reverse the order of the elements in the list. Right, so the first and last element get swapped, the second and second last element get swapped, and so on and so forth. Shuffle will shuffle the elements in the list. So show you that one. So collections dot shuffle T. So that randomly shuffles the elements in a list. Oops. Oh, sorry. Right, so the list is sorted at this point, and then I'm going to shuffle it, and so it's going to appear in random order. Right, so after shuffling, we've got front, middle, last, front, really last, last, middle. Right, if you run it again, you'll get a different order, right, because it's random. So if we run it again, front, middle, middle, really last, last, front, last. Right, so randomly shuffle a list. Occasionally handy. Reverse and sort. Right. And there's a whole bunch of other methods in collections as well that you might find some use for at some point in time. Right? Again, click the link, read the documentation, and see, to see if there's any methods there that are of interest to you. When you read the documentation for this class, it's going to be a little bit awkward for you at this point because the documentation, because the classes like lists are generic. And you don't know enough about the generic type mechanism to actually be able to read all of that documentation and have it make sense. So you actually won't be able to read this documentation properly until the end of the course. That's just the way it goes. Right? We're not ready to talk about generics in all their gory details yet. Yes?
I assume I know how that's going to work, but when you use the remove function,
yeah.
you give it like the first index, it shifts
everything over. Yeah, it shifts everything over. Yeah. Okay, can you, oh, sorry, what time is it? Okay. If you want to iterate over the elements in the list, and it turns out you often want to look at everything in the list, you can just write a loop, right? So you have both styles of Java loops available to you. Right? So for example, I can use a for each loop in this case here. Right? So this little snippet of code, I think, is looking at a non-empty list, and we're going to look for the shortest string in the list for whatever reason. Right? So the shortest string, I'm going to assume is the first string in the list. Right? The length of that string is going to be min length. Right? So I guess ask the string for its length. And now I loop over all the elements in the list. Right? So for each string s in the list t is how you read that. Right? And then it's just the usual search, or the usual search code here. Right? If the length of s is less than the min length, I found a new shortest string. Right? So min length becomes the length of s, and then the shortest string becomes s. And away you go. Right? And that'll find the shortest string in a list. If you want to, you can use a counting style loop as well, right? A C style loop. Right? So starting at index 1, right? Because we've already processed the element at index 0. Right? So starting at index 1, right? The index I has to be less than the size of the list. Right? Each time through the loop, increase the index by 1. Right? And now here I use get I, tget, to get the ith element out of the list. And then the rest of the code's the same. Same code. This time you actually do it the right way. Right? So here, turn that code into a method. Right? In the method, this method only works if the list is not empty. Right? Can't find the shortest string in an empty list. Right? So if the list is empty, throw an exception, and otherwise the code stays the same. Right? Oh, simulating odds. Okay. So now we're actually in the position to actually do something with a list. So if you want to simulate the odds of rolling a dice, it's pretty easy to do. Right? You just pretend you roll a pair of dice many, many, many times, count the number of times you see the value 2, 3, 4, 5, 6, 7, and so on up to 12, right, for two 6-sided dice. Right? You guys, if you've taken a stats course, you already know how to compute the probability properly. Right? this table here lists the probabilities, right? But if you haven't taken stats yet, you could solve this problem just by doing simulation, right? So in order to simulate rolling a dice, you need to know how to make a random number. So in Java, there's a class called random in the package java.util. Right? So that class there lets you make random Boolean values, so random true false. So that's useful for flipping a coin. Right? Lets you make random ints, longs, floats, and doubles. Right? If you want to know how it does it, you can click on that link there. Right? So that tells you the actual algorithm that it uses. If you want the documentation for it, just click on that link there. Okay, so if I want to compute the odds of rolling 2 dice, right? So what are the odds of rolling any particular value? Right? The way I'm going to do it is as follows. So I'm going to make a list, right? And I'm going to add 13 zeros to the list, right? Why 13? Well, I can roll the numbers 2 through 12, right? For the index, I want to use the value that's rolled, right? So in other words, I'm not going to use index 0 or 1 in this case. Right? But I do need 2 through 12, so that's 13 elements. Right? And then I'm just going to write a little loop that runs n times. Right? I'm going to roll 2 dice and get their sum. Right? So suppose I get a 5. Right? Then I'm going to go into the list. Right? So at index 5, I'm going to get the current value, which should be 0 at the beginning. Right? And then I'm going to add 1 to it, because I just rolled a 5. So in other words, I'm going to keep count of how many times I rolled the value n. And I'm going to do this a whole bunch of times. Right? Then to get the odds, you just divide all the elements by n, right? The number of times you did the simulation. So solve the problem using Eclipse here. All right, so let's do that. Instead of, do I have it handy here? I don't have it handy here. All right, so it looks like we have to do this from scratch. Okay, so we make a class. I guess we'll do this, yep. So we'll call this dice odds. Call it whatever you want, it doesn't matter. Right. Put in a little main method. All right, so step 1, make a list. Okay, so we make an array list. I'm going to count the number of times I roll any particular value. So to count stuff, it's going to be an array list of integer. Right, so we'll just call this count. New array list, like that. Okay, now when you type that in for the first time, Eclipse is going to complain. Right, so you see there it's underlined in red. You can see here it's underlined in red. Here you see a little X. Right, if you just hover over the error, it'll tell you what the error is. So it says array list cannot be resolved to a type. It's complaining it doesn't know what array list is. Right, so here you have to import the array list class. Unfortunately, it's the first of the 16 quick fixes available to you. So you just click on that, and then it inserts the import statement for you. Right? Array list lives in the package java.util. Right? Okay, so I want to initialize the list. I want to put 13 zeros in the list. So just a little loop. 13. Count.add 0. Right, so add the number 0 13 times to the list. Right, so now I have indexes 0 through 12 available to me, right, which is what I want. Okay, now I need to roll the dice a whole bunch of times. Right, so int n equals, I don't know, let's do 1,000. Right, and now I'm just going to write a loop that runs 1,000 times. So right, each time in the loop, I want to roll 2 dice. Right, so how do I roll 2 dice? Well, I need a random object to do that. Right, so instead of making the random object inside the loop, I'm going to make it outside the loop. Right, I don't want to make a new random object every time the loop runs. Right, so I'm going to use RNG for a random number generator. And you just make a random object by calling the constructor. Right, so new random. Right, again, it complains. It doesn't know what random is. So random also lives in java.util. Right, and so notice that we can import that as well. Right. Okay, so I want to roll 2 dice. So let's call them D1. So that's going to be RNG dot next something. Okay. So next int, you can't read it. Next int returns a random integer between integer min value and integer max value. So that's not going to help me. I need a random value between 1 and 6. Right? The next one, next int bound, returns a random number between 0 and the bound minus 1. Right? So in other words, if I write, come on, next int, 6, right? That returns a random number between 0 and 5, which is almost what I want. Right? I want a random number between 1 and 6. So that's easy, just add 1. The second one, I'm going to do the exact same thing. Right? Every time you call next int or next boolean or next double, you get back a new random number. Like that. Right? Sorry, one of my TAs has an office hour. D1 plus D2. Right, there's your sum. Right, now I know that sum is between 2 and 12. So I'm just going to get the current count out of the list here. Right, so int current equals count get sum. Right, so whatever is stored in the list at the index equal to the sum, that's the number of times we've seen that value. I just want to add 1 to that and stick that back in the list. Right, so count set sum current plus 1. Right, plus 1 because we just saw the value one more time. Right, we just rolled that the sum one more time, and that's it. You're done. Right. So after the loop, let's print out the list and see what we get. So system count. Okay, let's see what we get. And we get the following, right? So that's the number of times you roll a 0, which is obviously 0. Number of times you roll a 1, which is obviously 0, right? Number of times you roll a 2 is 32, and then 65, and then 83, and then 7 is 189, right? So this really does look like a binomial distribution, which is what it should be, right? Notice that the end, they're not exactly the same. It's not exactly symmetric, but if you crank up the number of times you roll the dice, then you'll end up with a better and better approximation. Right? So for example, if you roll that 1,000,000 times, right, which even on my laptop will take no time at all to run, right, you'll end up with a pretty fair approximation of the true distribution. Right? Divide by 1,000,000 to get the actual odds, and that's how you simulate a random event, a random process in a programming language. Right? Even though this example seems pretty simple, I think everybody will agree it's not terribly sophisticated. This is the basic idea behind simulation in engineering and science. Right? You've got some random event that you want to simulate, so you simulate the random event and you just do it a whole bunch of times, and then average out the results, and or do some sort of statistics on the outcomes to determine what is the to simulate your random process. Right? All right, so there's an example of using a list and using the random class to generate random numbers. That's probably enough for now. There is another simulation problem that we can solve, but I'm just going to stop there rather than trying to start the next problem. So that's it for today. If you've got a lab at 1:30, I will see you over there next.